Hey everyone, today we're gonna be doing a lead code question which is to find count of a subarray with a fixed window. So we are given some array, num, and two integers, minimum value, you can say min k and max k. So we want to find like a boundary in a subarray where at least these two elements, like minimum element and maximum element, should be present. So we want a subarray where these two elements should be present. So, like array is this continuous part of an array. So these are some example, we'll look into it. So let's see the constant first. So they are saying like constant can like have, and this is our constant like element, you can say the element inside the array can have two, like minimum two element to 10 to power 5 elements, and the number can range from 1 to 10 to power 6. The number like inside the array and this minimum and the maximum value. So, like, let's see how to do this question with some example. What I'll do, like, I'll draw this with some same example we have in the array. So, let's take like what we have. We have our array. The first array was 1, 3, 5, 7, or you can say 5, 2, 7, 5, 2, 7, and 5. And this is our array nums, and we are given some value like min k and max k. So min k is 1 and max k is 5. So we wanted to find some subarray where these two values should be present. So if I say very brute force approach, what I can do, I can generate all the subarray. So I can start from this position, I can generate all the subarray starting from that position. I can start from this position, I can generate all the subarray starting with that position. So for doing so, my time complexity will be n square, and for storing that array, also it will be like n square. For both like TC and SC will be n square. Let's see, but how to do it very brute force way. What I can do, I can generate all the sub array. So if you see, this can be my potential answer, this can be my answer, this can be my answer. I'm not saying my answer, but like this is my subarray. This can be my subarray, this can be my subarray, this can be my subarray starting from one position. So what I can do, like I can start from this position, I can keep on like going and storing all the subarray. Later, like when I have at all the subarray, like I will be having 2n into n plus 1 by 2 subarrays. For this particular array, I have this many subarray. Inside that subarray, I need to check which all subarray have these two element in it. Sorry. So what I can say, if I have this window, do I have minimum and maximum both? So it is not having. So if I say you which all window will have that, so if you can see this window, or you can say this subarray. So these are the two subarray which have both minimum and the maximum value. So if I show you the next example, like we are also given one num, and it is having 1, 1, 1 and 1, and also the minimum k and maximum k. You can say previous was maximum. This is my minimum k. Both are given 1. So we need to find a subarray where there should be these two elements both. So if I say this whole array is like 1, 1, 1, 1, I need to include minimum and the maximum in it. So if I say this alone can be my potential answer, this alone, you can say this single single can be my answer. So I'll say okay, 4 is the answer for single single. I can include this as well. 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 And single single I have already considered. So I can alone consider this alone. I can consider this one. I can consider this one. So if you say I'm having like all the point as a subarray. So if I say you as per the formula, if I say n into n plus 1 by 2. So if I have 4 element, I'll say okay, 4 into 5 by 2. So I have how many? 10 subarrays will be generated using this, because all the conditions are satisfying for each and every subarray. But it was not a case in this one, because they told minimum element should be 1 and maximum element should be 1 in a particular subarray. So if I start from this position, if I start from this value, I can have my minimum at least till here. Okay, the maximum can be 5 in this two window. These two window will have minimum 1 and maximum 5. And if I increase my window size to anywhere, the 7 will become maximum for so on. You can say the next size window. Also, if I skip this part, I will I I will never have any one in any of the subarray if I skip this one. So for this example, I have two as my answer, like this window and this window. Okay. So how we have checked? We have generated all the subarray using our brute force approach, and for each subarray we checked is these two element present or not. If these two element is present, I'll say okay, count plus plus for that particular subarray. Okay, so that was our very brute force approach, but we can still optimize. Like our brute force was, if I say, okay, approach one was time complexity was n square, space also n square. Okay, it was our brute force to generate all sub arrays. Okay, this is our brute force approach. What I can say, I can still optimize it. I'll say, okay, approach to optimize. What I can do, last three questions, if I say in the last 3 days, we got some question on the sliding window pattern. Like you can say a two pointer approach or the sliding window. So what I can do, I can use something called two pointers and sliding window concept. Sliding, sorry, sliding window. So what I can say, okay, I will maintain a window. If you see, just for one example, if I show you for this particular case alone. So what I'll do, I'll take same example, uh, 1, 3, 5, 2, 7, and 5. Okay, what I can say, okay, I can start my left pointer and right pointer like this. If I'm just saying my, you can say a window size something. So I can start my left here, right here. What I can do, I can like increase my window size till I am having the minimum element in it and the maximum element in it. So what I'll do, once we are getting the minimum element, what I'll do, I'll keep my window size increasing. I will be checking if this is my minimum or maximum element as per this requirement. So for this minimum and maximum is this. So what I'll do, when I'll iterate, I'll just keep on checking, is this my minimum or the maximum? I will store that particular index if I found this element. Okay, so what I'll do, I'll just shift my, you can say, if I'm just getting all the number within a particular range. See, number one is belonging to like minimum, minimum, you can say, what was that? Minimum K. Minimum K, see, this, you can say this is something called X. What I can say, X should belongs to uh, less than equals to maximum of K and less than equals to minimum of K. So you can say minimum x should be minimum, like you can say equals to or greater than minimum, and see, I'm saying x should be at least less than equals to what, maximum, and it should be greater than equals to minimum. Okay, this is our element, minimum k, and maximum k. So this should belong in this category. X should belong in this category. So until it is satisfying, what I can do, I can increase my window size. Once, suppose if this is my window size, I'll say, okay, I'll keep shift my right pointer, I'll increase my right pointer here. This satisfy my window now. I'll still increase my right pointer. This can be like, this can be my answer. It is also satisfying. Like for this particular subarray, I have maximum this, minimum this. If I again shift my right pointer, I'll get 7. Now my 7 will become local maximum. I'll say local maximum. So you can say 7, you can say local maximum is not equals to the maximum of k. So this cannot be my potential answer. So like this particular x is not belonging to the given input criteria. So it should belongs to maximum of k and minimum of k. So this number should belongs to this category. Okay. Same way, if I say, if I'm using this approach, the two pointer sliding window directly, I cannot take that particular into the consideration, because if you see for the example 1 1 1 1, if I just keep on increasing my window size starting from left, I'll keep on increasing the left, a right. Also, if I shift my left pointer to, like, I have completely expanded my window, then I'll start decreasing, or you can just shrinking my window, but it will not give me the correct answer. So what I'll do, I'll use something similar to this window size, like the right pointer and a left pointer. But what I'll do, I'll just keep on storing the current, you can say, in a particular window, what is the minimum and the maximum along with the defaulters. Like something in not in this boundary will be like breaking our logic. So what I'll do, once we get something which does not belongs to this category, I'll say that is my something bad element, and I just need to store all those indexes. Okay, so what I'll do, I will be storing my local minimum and maximum indexes and the bad element indexes. So if you see this example, okay, I have a window, you can say 1 2 3 5, and you can say, I'll not take this much, let's see, 1 2 5 7 1 2 5, or you can say 1 3 4 and 5, and you can have 2 or 0 and 1, or I'll say here it is 0. Okay, it is 0 here, 5 here, 2 here, and 1 here. So this is I have a particular case, like this is a subarray. What I can say, okay, I'll start my left pointer, you can say left, or my some, you can say that left and right pointer, or just I can have one pointer. I can say I am just at particular index. What I will be checking, for now, our local, you can say local, or you can say index for the minimum value. I'll say minimum index. Okay, so I'll say minimum index and maximum index value I will be storing, but for now it is -1, like it is not present. Same for the bad element. So I have bad element, I'll be storing some index. So for now it is -1, or I can say for now it is not present. I'll say none, 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 none. I don't have any indexes for him. So what I can say, I can iterate over this array. I'll be iterating over this array. I will be checking the element. If it is belongings to this category, then fine. I will be checking if it is equals to the minimum element or the maximum element. If anyone satisfies this condition, I will be storing its index. So if this belongs to the minimum, see, we are given some minimum k and maximum k. So what I'll be checking, if this belongs to minimum k or maximum k, I will be storing its count or the, you can say, particular index. So this can be my minimum index for now. I'll iterate over this. This belongs to my category, but it is not a minimum or not a maximum. I'll again iterate over here. I'll get to, like, for now I am here. I move to here. I move to here. Now my minimum index is this. Maximum index is this. Why? What I can have? I can have, okay, this can be my potential answer. I'll say, okay, plus plus 1, or you can say count plus plus. Now, if I say, if I move again, you can say if I remove this, not remove, I'll just iterate to the next element, I'll get 7. So this is my defaulter. You can say if I include this one, it will not be considered until here, like any sub array before this or after this will not have my answer, because this does not belongs to this particular category. So I'll say, okay, this is my defaulter index. I'll just store this index. So let me write the index as well. So I have index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have 10 element. Okay. What I'll have, initially I have something something -1 or null. As soon as I'll get the minimum element, I'll be storing its index. So for now, minimum index is 1, because I iterated over here, I iterated over here, I iterated over here, I iterated over here. So till here, I'm just currently standing at this particular position. So I, till that position, I have encountered the minimum and the maximum. So this is our maximum, this is our minimum. I have got its index. So for now its index is 0 for the minimum and 2 for the maximum. So I got this point. Okay, now when I iterated over here, my bad index become what? 3, because I got something which does not belongs to that category. So what I need to do in each and every pass, I will be checking if it is like less than equals to 1 or not less than, like it should be in this category. If it is in this category, then I will be checking if it is a minimum element or if it is a maximum element. So in a single go, I will be checking all three conditions, whether it is belongings to this case or not, whether it is a minimum or not, whether it is a maximum or not. Whichever condition getting satisfied, I will be storing all these elements. Like for minimum, I will be storing its index. For maximum, I will be storing its index. If it is not in this case, I will be storing its index as a bad index. You can say bad element. Let me tell you like why we are storing this one. Suppose if I consider this element, something before this, something after this will not be taken into the consideration if we include this element. So what I need to do, if I am just iterating next to it, I will say, okay, take the size of the element. You can say this can be my potential answer. I'll say, okay, take the size of the element after this. So I'll say my new start position will be like, you can say bed index plus 1. So what I'll do, I will be starting after this element, or you can say I'll not take this one, I will be starting over this array, skipping this element. So if I wanted to know the size of the element or size of the array, I'll say, okay, for this particular case, just if this particular is a size n, I'll say just remove the bed index, so it will give me the size of a current sub window, you can say sub array. Okay, so I'll again iterate over this array, I'll iterate over this array. So for now, I again got my minimum, I'll not, I got my minimum, I'll change this to 4 because I now got the recent minimum. And if you say here, this does not belongs to our category, I mean like it is not in our case, like it is not a minimum, it's not a maximum, this belongs to category. So I'll just iterate over this. Now if you see, if I have got 0, this also does not belongs to this category. It is like greater, you can say minimum than 1. You can say if my minimum and maximum given is here 0 and 1, for minimum I have 1, for maximum I have 5. So 0 does not belong to that category. Now my defaulter become this element. So I'll say, okay, defaulter become this, index will be 7 for now. Now, again, either I can reset this element to -1 or 0, 0. You can say none, none. I don't have this now, as per now. Again, if I found this element, I'll say, okay, I got the recent maximum. The index is 8. Okay, I'll just iterate. I'll got 1 again, where a 10 index. So for each index, I will be having some range. And how can I say like how many subarray will be created over here? So I'll say, okay, subarray starting after this particular bed index. Suppose for this example, if I have this element, I can say this array. So I don't have any defaulter until here. But I can say, okay, I can start from this particular subarray. I got 2 cases. So this can be my answer. This total can be my answer. So for finding it, what I can do, I can like decrease, or you can say remove this from my size, and I can take any one of them, like minimum index of them minus the bed index. So it will give me the answer. So what I mean to say, like let me show you with some help of code. So by seeing the code, you can get much like insight what I'm saying. Okay. So let me increase the size. Okay, I guess it will be fine. So what I will be doing, I will be storing some count. Let me take the size as well. So count will be 0 for first and size will be nums. Now what I can do, I can have the indexes, or you can say I have some minimum element, I have some maximum element index, I have some bad element index. Okay, all will be, for now it will be -1, and -1, which means it does not belong to our category. It is like out of bound, you can say. Okay, now I will iterate over this number. So for now I'll say, okay, index and that number in, like I'll say I will be using a function enumerate to just to get the index and the number at same time. So I'll say okay number. So I'll get the number and the index at same time. I'll say okay if this number is greater than what max k, okay, or the number is less than min k. So it means it does not belongs to our category. I need to store the bad index. So bad index will be equals to what? Current index. Suppose if this element was equals to max k, what I can say, okay, this can be my local, you can say local maximum. So I'll say, okay, it will be our max index. For now, store its index. Same for now, it can be my minimum as well. If the number is minimum, I'll say, okay, minimum index will be this index. If this number is our minimum number, minimum k, if it is equals to minimum k. And any of the conditions satisfy or not, what I need to do, I need to find the sub-array which is contributing to it. So I can say, okay, what I can have minimum of, I can say index, you can say minimum index and maximum index, whichever come first, I'll take that part, max index. I'll say, okay, remove the, you can say bad index part from it. So it will be giving me some value, but it can be a negative one. So what I can say, I need to take either positive or for now I can take 0. If this number goes to previous, like the bad element is coming before to our this element. So I'll say that's fine. But if the bad element is coming after the minimum or the maximum, it will be giving me the negative result. So I'll take maximum of them, like either if condition gets satisfied, I take the minimum of this one, like minimum of minimum and the maximum element minus the bad index element, and if it is giving me negative value, I'll say okay, take 0 for that case. Now I'll return the 0. I'll return the count, which will be giving me the count of subarray. I'll simply compile this code. Let's see whether it is working fine or not. So it is giving me some syntax error. They're saying okay, I need to have equals to comparison. Okay, I'll run this again. Let me see it is working or not. So as I can see, it's loading so far. Okay, it's accepted. Let me submit this code. Let me see if it is working completely fine or not. So as I can see, this code is optimized and we have done this in an order of n without taking any spaces. So this code is like done in a linear time complexity. So hope I guess you got this solution. Thanks for watching.